the back plate behind here, is where the actual magic tape is, which is also commonly basically a strip of Velcro, the hook side. And the significance of this is that the thread comes down from the sewing head over the front of the needle bar and then down through the eye of the needle. And when the machine is done sewing with this, the upper thread hook, or what's called the catcher, will grab the loose end of the thread and pull it between these two plates, and it'll catch and hook naturally in the strip of Velcro. So there's 3 small screws, Phillips screws, that hold this. So what we'll do is to have a look at it, we'll remove this plate, and you can see how this is mounted. So these are non-standard, very much finer screws, so you want to take care in removing them. So it can help on some operations, maintenance procedures, to have a jeweler's set of screwdrivers that will really help you get at these places. So as you can see, as I work this loose, the threads, the ends of the thread will start coming off. And now you can see the thread holder assembly is completely off. And what you're looking at is 3 screws. And then this is, again, what's called a thread holder assembly. And I'm sorry about this. The Velcro is actually mounted. It's more like a fuzz. It's actually mounted along the back here. So, and it's pointing downwards. So the magic tape itself is adhesed onto this. So basically you're just replacing that and sticking it down on the center there. There's no fine adjustment as long as the Velcro or the magic tape is stuck approximately up the center there. So it's good to clean it, but over time, after maybe 2-3 years of hard use, you may notice that the end of the thread, if we zoom in here, you can see without the presence of the Velcro, the thread hangs loosely, even though it's still through the eye of the needle. And an important thing that to note is that between the bar of the thread holder, lower bar of the thread holder assembly, and the upper plate are small spacers, and I don't know if we can get a close-up of this or not, but these are very, very small spacers. You're going to get an idea for size there. So, there's just small little cylinders that the small screws pass through, and there's 3 of them. So make sure you don't lose them, and that will keep the bar parallel in the proper space between the upper plate and the lower plate. And also, Lorna, if you can see, you can see how the plate's mounted. You can see that if we look at it from the side, it's sort of a C-shape. Hopefully we can get this on camera. It looks kind of flat, but actually it's C-shape, so just make sure the C faces downwards. And again,
okay,
flat. So this faces downward so that the flanges are facing down and away. You don't want it to cup up so that it can sort of cup towards the thread. You want the cup side facing downwards. So, and I just dropped the spacer, so the spacers can actually sort of stick to the upper plate. So make sure you account for all 3 of them, and they're very, very small. So in replacing this, what we would do is simply place our plate back. I'd probably start with 1 screw, and I can see what you're talking about. The holes are machined so that there's a front end that's a little bit. If you can see that hole, the front end is more is a little bit wider than the back end. So make sure that the slightly wider portion is facing downwards, and the shorter portion is facing upwards. So that's the thread holder assembly, and how that's put together. Replace the lower plate to the thread holder assembly is I'm going to go ahead and stick the spacer and the screw together, and I'm going to hold it together with the screwdriver. I'm going to try to put this back on. Run for its money, even though it's much smaller, lighter duty, and of course less expensive in price. We've had this machine on the market for over 10, 11 years, since 2003, and it's been continuously improved, so it has an excellent service record. And a lot of people are pushing this machine very successfully beyond even its official limitations. And of course, as this series of ongoing webinars is designed to help owners keep their machines running no matter how old they are, because the more the machines run, the more profit they provide for you. Pictured here also is the 7-needle Journey machine, and it's a much lighter duty version of the Voyager. And for people that may be wanting to look on the entry level to just get in, or maybe need some light capability. So between the three of them, we offer a good range of capabilities. So bringing it back on topic, with this webinar here, what we're going to show you is if something severe happens with the Happy Machines, if you run them at high speed, there's always operators who may forget something. You slam into a hoop or something, a lot of thread grabs around the rotary hook. That's usually one of the quote-unquote worst things that may happen to the machine, and it gets out of time. So, Lorna, I know you just had an incident where you had your rotary hook adjusted. Do you remember what brought your machine out of time?
I don't think I had my needle properly tightened when I put it in. The needle I was using broke, and the tip of it was lodged right in the rotary hook.
Okay, so the rotary hook being around here, and that can, of course, lock the hook up, and there's a large drive system behind here that's going to try and keep that turning. But if this locks up and resists that, then of course the shaft's going to turn, while this thing is held in place, and that gets knocked out of time. So to put the rotary,
would not turn.
I'm sorry, go ahead.
The rotary hook would not turn.
Right,
until
exactly.
we got.
Okay, so just to kind of talk about a little bit of sewing theory, we have actually a website called happymb.com, and then on that site I have something called that talks about the way a machine makes a stitch. This is called a lock stitch machine, and this is an illustration, an animation of how the machine makes a stitch. This is not just embroidery machines, but the sewing machine part of an embroidery machine makes what's basically called the lock stitch. And what you're seeing here is that the needle comes down, and then the hook, which is spinning underneath the bobbin case that we'll get to in a minute in red, is spinning around the bobbin, and it's meeting the needle. We're actually seeing this from the back. It's meeting the needle at the back and grabbing the thread, and as you can see, it's grabbing the green thread and wrapping it in a half twist around the blue thread, which represents the bobbin thread underneath. So what's very important to notice here is that as the needle comes down, if you notice very carefully, the needle's just starting to come back up as the hook is arriving behind the needle. So the red hook tip is arriving just as the needle is starting to come back up. And that's what's called the timing. The needle goes up and down, but only when the needle is starting on its way back up is the only time that the hook can arrive right behind the eye of the needle and properly grab the thread. And of course, when everything is working well, then it grabs that very reliably, and you don't have to worry about it. The factory manuals recommend that you check this every 6 months just to make sure everything's good, and then maybe adjust it once a year in case there's a problem. So during normal operation, that's what you're expecting. So this should be a rare incident that you don't have to do, but usually it happens. Murphy's Law says that this is going to happen at a rather inconvenient time. So, and since it's really a matter of adjusting something that is loosening a couple of screws, putting something back to the proper position, and then tightening the screws again, then we would rather not you pay a lot of money to a technician to come to your site if this is something that we can teach. And of course, there are a few that where they may see that as better to have the technician, but we want to give the choice to you. So the first thing we want to do is we want to remove the sewing plate here so that we can expose and be able to see the needle as it gets close to the rotary hook. So that's done with a screwdriver. This is what's called an offset screwdriver. It will be bent on both ends, and this comes standard with your machine. And of course, our technicians have their own as well. But you're doing so. The machines come with many of the same relevant tools that the technicians have. Now, we're not going to unscrew this all the way with a screwdriver. All we need to do is just loosen it enough that the screw head comes just above the surface of the plate, and we can kind of spin this off with our fingers. So that's above the plate, and we can spin that very quickly off with our fingers. So it's probably a little bit odd to see a quarter of my head in the shot here. But so anyway, we'll keep on going. And my name is Rene Rosales, and I am the educator for X264 Incorporated. And so what we're going to do is we've started to remove this plate. You can even, I've only removed one screw, but you can actually swing the plate out of the way. And let's go ahead and zoom in a little bit more closely so you can see what's going on. Angling the camera down a little bit and get a little bit more tight on the sewing hook. So what you're seeing is not just the sewing hook, but the bobbin case assembly and everything together. Let me get that in focus. Okay, so what we want to see is the relationship between the needle and the hook. So we want to get a couple more things out of the way. You can see I've swiveled the plate out of the way. I can actually continue to remove this last screw. I'm going to go ahead and do that. It looks like it'll be much better for us if we remove this completely. So this plate is completely out of the way. We also want to remove the bobbin case, which is something you would do naturally anyway to refill that bobbin. And then what we're looking for is you want to get, ideally the factory manual says put it to a middle needle. In practice, it's really whatever needle that you're using. And with the Voyager machine, the way to bring the, there's a couple different ways to bring the needle down. The control panel will actually let you do this yourself electronically. But the way I like to do it is we'll go ahead and drop the presser foot. And Lorna, this is the way you're going to do it with your previous generation machine. So basically, you just bring your presser foot down. So we'll press the P foot button or presser foot. Okay, so now that the foot's down, then we can actually grab the needle and just pull it down into place. Now, this basically manually puts the machine just like a car in drive. And then what you're doing, just like pretend that with a car motor, you can actually spin the, push the car, the wheels turn, and with it in drive, that means you're turning the drive shaft and all the engine bits inside, so you can see how the engine is behaving in slow motion. That's exactly what we're doing here. So now I'm going to go to the back of the machine, and on the back of all Happy machines, there is what's called a timing wheel, or in sewing machine parlance, a hand wheel, that you can actually turn the entire machine through its entire sewing cycle. Now, on the Voyager, I can grab this by hand, so you can actually see this hook spinning. Or the machine also comes with a toolkit. This is a 3mm hex wrench, and on all Happy single head machines, can actually grab this wrench, grab that center wheel with the center nut, which is a 3mm hex nut, and turn it through the entire sewing cycle so that you can see here's the needle going down, the needle coming back up. I can go backwards through any point in the sewing cycle here so we can see where the position is. So what we want to see is where the needle is supposed to meet the tip of the rotary hook. And on the Voyager machine, and actually also the Journey machine, that's at 25 degrees. So the back of the machine has a marked degree wheel, and we'll show you that. And that is right at the 25-degree position. Now that doesn't mean anything right now at the the level of zoom we're at, unless you know exactly what we're looking for. So let's look at something here. This is one of our training guides that's available for free on the web. And in our chapter 4, we have our instructions on timing the rotary hook. And if you look very closely, when you remove the rear cover, you'll see this hex nut here, which I'm turning. And there's a pointer on the left side, and you want to basically turn the wheel so the pointer is at 25 degrees. So once that's at 25 degrees, you're basically bringing the needle to the point where it's just starting to come back up. So on the next page, we have a really close view of the rotary hook and what's supposed to be happening. So the hook is spinning counterclockwise. So this tip right here is turning and arriving just behind the needle. So let's do that in our live shot here. So if you can see, let me see if I can get us any closer. And if our focus will cooperate, then we'll be able to see that nicely here. So let's see if we can cooperate. We may be as close as let me see, zooming out a little bit. Bear with me, guys. Close up. All right, so our focus doesn't want to cooperate, which is okay because I can use our still shot so that we can see. I do want to show the rotation here, and we can't show that. We're close enough that we can see that rotation. All right, so the rotation is that you're seeing that the tip of the hook is arriving right behind the needle. So let's see if you all can see that well enough. I'll use the cursor here. So what you're seeing is this is the back tip of the hook. We're looking for the front tip of the hook. So let me tell you all what. And once you can see this is basically your main target for hook timing. Okay, that did it. You can actually see the forward tip of the hook. You can see that tip is arriving as the needle's starting. If you can see right here, the needle bar is starting to come right back up just as this tip right here is arriving right behind the needle. So if you see in the larger illustration, this is the tip here that's arriving behind the needle. So if they are meeting at 25 degrees, you know your timing is good. And finally, if you look at the adjustment, you're not only turning left to right in time, but we're also turning the same view to its side. And this is the same picture, even though it's the same, it's in a different color. I took these shots not more than 2 minutes apart. The needle, there should be a slight gap between the front of the back of the needle and the tip of the hook. So let's illustrate that live in the video, so you can see the relationship of these two pictures. So kind of going around to kind of bringing the camera around here, what we'll do is I'm setting up our view here so you can see this, is if we swivel around from the front, we'll try to keep the machine, you can see our view is kind of swiveling. Now we're swiveling around to the side, and you're seeing the relationship on the side, and what you're looking for is that the needle, you should barely be able to see the needle move backwards when you push the needle backwards up against the tip of the hook. Now, we're not having any success showing that on camera, but what you're looking at is basically a business card width between the back of the needle and the front of the rotary hook tip. So since you kind of see what we're looking at, you're seeing this same view, and if you push on the front of the needle with a screwdriver very gently, this should bend and flex and just touch the back of that tip. And that should be less than half the width of the tip of a needle, so you should barely see that move. So that's proper timing and distance between the two. You basically just want to allow, you basically only want to just allow a piece of thread to be able to slip between those two. So what you're doing is you're adjusting 3 screws on the side here on the neck of the hook. By loosening these 3 screws, you can then finally adjust this hook and then tighten those 3 screws down, and then you're pretty much done. So the only difficulty in this is just making sure that meets perfectly and tightening the screw. And that's pretty much it. So in a nutshell, we're removing the needle plate itself. And on the Voyager, we bring the pressure foot down and we bring the needle bar down so that they're engaged and like your car is in drive, so that when you turn the main shaft, everything moves like it's driving, like it's sewing, just like your car's. If you take it out of neutral and put it into drive, you press the accelerator pedal, the car moves. This machine is in drive, but in very slow motion, so that we can see it do everything in its stitch. So everything in making a stitch. So we're bringing it to the point where the point of the needle is just coming up, and the tip of the rotary hook is arriving behind that needle and making sure they meet at 25 degrees. And if it happens to be the other machine behind us, which is the 15 needle, the timing is the same, except that you're at 23 degrees. And then for our 7 needle machine behind us, the procedure is the same, except we would do that at 25 degrees. So the Happy machines all work just like sewing machines, and the adjustment points are here and publicly available in case anybody wants to walk through this. And that's rotary hook timing in a nutshell. And if you can check that timing, that's enough that should help you assure that you can make a reliable stitch for years on end with your Happy embroidery machine. The needle, if you haven't threaded it already. And you want to make sure it passes through this upper loop here as well. That helps guide it into the groove in the front of the needle. Now that that's threaded correctly, again, like we were just showing, we want to go ahead and hook the thread with our tension gauge. And again, this is like a fish scale. There's a little indicator here. So as I'm pulling, you can see that, and you can see that I've loosened it just for demonstration purposes, only to about 30 grams of tension, because you can see that little red mark. So we want it to be up in right around 100, 120 grams for, especially as a good starting point. So to adjust that, to tighten it up, again, this is needle 1, or the rightmost needle. So we want to follow that all the way up the sewing head to the first and second tension, the 2 rows of tensioning knobs. And we want to pull, basically I'm going to pull the thread downwards, and as I'm doing so, I'm going to tighten one of the knobs until I can feel it being heavier. And then I want to measure it. I know that that's still too light. So so now that I can feel the difference, in making my first adjustment, I'll go and adjust the opposite knob until I can feel it making a difference. So notice it takes a few turns until I can feel that added weight. So I'm going to continue adjusting back and forth until I can feel the weight becoming kind of close. So, and of course you can keep rechecking with your gauge in case so to take the guesswork out of it. So I did this a few times knowing that this is only going to take, this would take a few turns. So I'm going to go ahead and pull, and let's measure that pull and see how close we got. So hooking that in, let's go and see on camera how we did. I'm at about 100, so I'm just a little bit short. So I'll go ahead and tighten it just a little bit more until I can feel a difference. Now I'm at about 115, so that's good. So all I did was tighten the upper knobs just a little bit more. So hopefully that helps a little bit. Does that make any sense there, Lorna?
Yes.
So basically what you're doing is you're making sure that the two knobs are sharing the load of the tensioning job between the two of them. One's not over tight than the other, but it doesn't have to be at a strict position. As long as you're turning them enough to make a difference that you can feel in your fingers, then you can tell. Then the thread tension gauge will also show it on the gauge as well. But if you don't trust your fingers for a heavier or lighter weight, you can always just hook the thread tension gauge to the thread and always go by its measurement. Again, you just kind of hook it like that, hook it nice and firmly in the hook, and it grabs. You don't even have to tie a knot, and then pull, and you can see as you're pulling downwards, it stabilizes on a particular tension, so that's what you're looking for.